Now we are back with the joint continuous distribution. Now for the joint continuous distribution, previously we saw the joint discrete distribution. So we say that to allow me use RV as we saw from the previous module. RV is an acronym for random variables. RV, random variables. Two RVs X and Y. RVs X and Y are said to have a continuous distribution with a joint probability, density function. Now the probability density function here is f xy. Recall from the previous module was fx. Yeah, but I have been always explaining this is multivariate. So joint probability density function fxy if the same properties hold. Property number one, probability is non-negative. Probability is non-negative, and this is true. This is true. This is true for all values of x and y within this range. For all real values of x and y, that is true. Then the total probability is 1. Now, for the other case, remember for continuous, we use an integral. And an integral is interpreted as the area under a curve. So the area under a curve, these are now double integrals. Hopefully from calculus 3, I think, you have looked at multiple integrals. So in the other framework, we are using a single integral, but now here we are operating in x, in terms of x and y. So it is a double integral of dy dx. And from Cal theory, you looked at double integrals. Then also property 3 is that the probability that x, y are within a particular subset of the Cartesian plane. This is the same as having an integral, a double integral over that region xy dx dy. The order of those dy dx doesn't matter. You just have to be careful when dealing with them. In particular, what this means is that in particular, if a is less than x, less than b, and c is less than y, less than d. If x ranges from a to b and y ranges from c to d, then for one to determine, then property number 3 says that then the probability of A less than X less than B, C less than Y less than D. This is the same thing as the integrating. Now you see X starts from A to B and Y starts from C to D. F, X, Y, C to D, that is the Y, A to B, that is the X. That's what that property says. Then also, if X and Y have, if they have a joint continuous distribution, if X and Y have a joint continuous distribution, then the following statements are true. If X and Y have a joint continuous distribution, then what does the first what I say? For a point-wise, this is maybe I first note it down. The probability of X, Y at a particular point, probability at a particular point. Now here, for continuous, this is not discrete. This is not discrete. This is not discrete. So continuous is over a certain range. It's over a certain region. It's over a certain range. So probability at a particular point, this is probability over a region. It implies that probability at a particular point should be 0. Is 0. And this is the same thing as saying that any individual point or any infinity sequence or any infinite sequence of points in the xy or any infinite sequence of points in the xy plane has probability 0. Then also the other important statement here is that the probability that x, y will lie, probability that will lie on any specified straight line. I hope I am This thing is a bit stubborn at times. The probability that xy will lie on any specified line in the plane. This is still pointwise. Still pointwise. In the plane is as well as 0. Finally, one dimension curve is still pointwise. This is still pointwise. So any one dimension, any one dimensional curve, one-dimensional curve in the xy plane has, this is still pointwise, so probability is still 0. That's probability. Let us now look at some examples.